Hey guys, welcome back to chapter 7. What we're going to do today is we're going to look at our first application of stoichiometry. So we're going to apply it to a certain scenario. We're going to apply it to something called limiting reagents or limiting reactants. You'll hear both terms used. So let's go back to our crappy pancake recipe. Okay. So again, our recipe, remember, is 1 cup of flour, 2 eggs, half a teaspoon of baking powder, and 5 pancakes. So let's say that I go to my pantry. I have 1 bag of flour. I have a whole box of baking powder. I open up my fridge and crap, I only have 4 eggs. What is the maximum number of pancakes that I can make? Well, with a bag of flour, I can make a gazillion pancakes with that bag of flour, right? And with a whole box of baking powder, I can make a gazillion pancakes with that box of baking powder. But the 4 eggs is going to limit that a little bit, huh? So with 4 eggs, the maximum number of pancakes that I can make is 10 pancakes. So what is limiting me from making 11 pancakes or 15 pancakes? Yeah, the eggs are limiting me. And if I want to make more than 10 pancakes, what am I going to have to do? I'm going to have to get more eggs. I'm going to have to find more eggs, right? Either go out and pick some up because I don't actually live on a farm, but I live on a farm, go pick some eggs up, go to the store, ask a neighbor. But if I want more than 10 pancakes, I'm going to need to find some more eggs. And when I put more eggs in that reaction, more pancakes are going to come out the other end. So the limiting reagent or the limiting reactant in this case is the eggs, okay? Something else to picture while we're on this page is, let's say I did make my 10 pancakes. So I put my flour in, I put my eggs in, I put my baking powder in, made my 10 pancakes, put them to the side. When I look at the counter over at my ingredients, what am I going to see sitting on that counter? I'm going to see extra flour sitting on that counter. I'm going to see extra baking powder sitting on that counter. I'm not going to see any eggs though, right? The eggs will be all gone. So the other 2 are in excess. They're still sitting over there on the counter, and likely what I'll do is just put them back in the pantry for another day. But it's a good image to get in your head to see, yeah, there's going to be some of those left over. Okay. So the limiting reagent or limiting reactant is the reactant that makes the least amount of product. So going through our ingredients again, we have enough flour to make a gazillion pancakes. We have enough baking powder to make a gazillion pancakes. We are limited by the eggs. So the maximum amount of pancakes that I could possibly form is 10 pancakes. That's it. Okay. So easiest way to do these problems is just to dive in. We're going to have to dive in head first. I'm going to make the assumption that you are fairly comfortable with these stoichiometry problems. So hopefully you have practiced them. I'm going to go through them pretty quickly today. So hopefully you can tag along because you practiced and you have a good understanding. So here's the problem. Suppose we have 20 grams of sulfur trioxide, 10 grams of water, and I want to know how much sulfuric acid, so sulfuric acid is H2SO4, how much sulfuric acid can we make? Okay. So to do this problem, looking at it, you're going to say, oh, that's easy. You have more SO3, so the water is going to limit you from making more H2SO4, so let's do stoichiometry with the water. But be careful. That's not always the case. We need to go through the full stoichiometry evaluation from SO3 to H2SO4. So that's going to be step 1 is SO3 to H2SO4. And then step 2 is to go from water to H2SO4. And we're going to see which one is the limiting reagent. We're going to see which one limits us. So when we get to this step here, we're going to pick the smaller amount, right? So when we were looking at our pancake recipe, we can make a gazillion and a gazillion. But when we have eggs, we can only make 10 pancakes. That was the least amount of product. So that was the most we can make. So same thing here. We may be able to make a gazillion from SO3 and only 10 from the water, and we would pick 10. We would pick the smaller amount. Okay. So that's going to be the process. Stoichiometry from SO3 to our product. Stoichiometry from water to our product. Pick the smaller number. Right, so let's clear this slide. Let's do it this way. All right, so let's start with this 20 grams of SO3. So I've got 20 grams of sulfur trioxide. And remember, our map is going to be from grams of sulfur trioxide to moles, sulfur trioxide, moles of our product, grams of our product. Okay. So we start with grams of SO3. First step is going to be just a grams to moles conversion. And 1 mole of SO3. Let's do the molar mass real quick. All right, so 1 mole of sulfur trioxide is 80.063. So I'm going to multiply across the top, divide by the bottom. So 20.0 times 1 divided by 80.063. And that's going to give me 0.2, we'll say 5 moles of sulfur trioxide. Okay. Step 2 is the new step we introduced in this chapter. We're going to go from moles of sulfur trioxide to moles of our product. So, let's go to a different color. So take the answer from our previous step. And then let the units guide us. So moles of sulfur trioxide are going to go on the bottom. Moles of our product on the top. And how do we get the numbers? We're going to look at the balanced chemical equation. Okay. So what coefficient is attached to our product? Well, there's an implied coefficient of 1. And what coefficient is attached to SO3? Again, an implied coefficient of 1. So we've got 0.25 moles of our product. Okay. So last step is moles of our product to grams of our product. So I'm just going to go ahead and erase this and just do this step up here. All right. So let me just go to a new color. All right, so I'm going to take my answer from the previous step, 0.25 moles of H2SO4. And I'm going to go to get out of moles of H2SO4 and go to grams of H2SO4. So in 1 mole of H2SO4, let me do the molar mass real quick. I get 98.078. Okay. So multiply across the top, divide by the bottom. So I get 24 points, we'll just say 5 grams of H2SO4. Okay. That's step 1. So what we calculated is that if we start with 20 grams of SO3, we can get a maximum of 24.5 grams of our product. Now we have to do the same thing with water. So we're going to do the same process starting with 10 grams of water. Okay. Ooh. Looks like I'm going to have to erase all this. Okay. All right. So up here, I'm just going to write this number because I'm going to have to erase it and use this slide. So we can get 24.5 grams of H2SO4. Okay. All right. So now let's do this same process, but we're going to start with water. And if you guys would like to challenge yourself, now would be a good time to maybe pause the video, do your stoichiometry with water, and see if you get the same answer that I get. Okay. So our process is going to be grams of water to moles of water to moles of our product to grams of our product. Okay. All right. So we're going to start with 10 grams of water. Do a gram to mole conversion. So grams of water go on the bottom, moles of water on the top. So in 1 mole, we have 18.015 grams of water. Multiply across the top, divide by the bottom. And I have 0.56 moles of water. Okay. So second step is to go from moles of water to moles of our product, to moles of H2SO4, right? So we want to see how much of that we can make. So I'm going to take my answer from the first step and set up my train tracks. Moles of water on the bottom. Moles of my product on the, I don't know why this is breaking up. Moles of my product on the top. All right. Now we're going to look at the coefficients from the balanced chemical equation. So what coefficient is attached to our product? Yep, it's just a 1 again. What coefficient is attached to our reactant? Again, 1 with the water. So multiply across the top, divide by the bottom, and we still have 0.56 moles of H2SO4. Okay. Then the last step here is to go from moles of H2SO4 to to grams of H2SO4. So I'm going to bring that up here, 0.56 moles of H2SO4. And just do a mole to gram conversion again. If I didn't save it, I'm going to have to calculate the molar mass again. 4. Again, it's 98.078. Multiply across the top, divide by the bottom. So 0.56 times 98.078, and we can make 54.9 grams of H2SO4. Okay. That's step 2. Step 1, start with SO3, go to our product. Step 2, go from water to our product. Now the last step is to compare the two. Okay. All right. So with 20 grams of SO3, I can make 24.5 grams of our product. Or if you want to think about it this way, I can make 24.5 pancakes. And with the amount of water that I started with, I can make 54.9 grams of our product, or 54.9 pancakes. Okay. So it's asking how much H2SO4 can be made. Here's where we're always going to pick the smaller number. So the maximum amount of our product that I can make, and the answer to this question is 24.5 grams of H2SO4. Okay. I have enough water to make 55 grams, right? But I only have enough SO3 to make 25 grams. If I wanted to make more, what would I have to do? Yeah, I'd have to find more SO3 and I'd have to put it into the reaction beaker, and there's plenty of water left over. So when I add the SO3, more of my product would be made. So the limiting reactant or limiting reagent is SO3. All right, so here's another example. Why don't you guys pause the video, work through this one, and then I'm going to very, very quickly walk you through it at the end. Okay, so here's our roadmap for success. So the first thing you're going to do is you're going to start with grams of magnesium, and you're going to take that to grams of magnesium oxide to the product. So grams of magnesium, moles of magnesium, moles of magnesium oxide. And if you wanted to, you could just go ahead and take that all the way to grams of magnesium oxide. Okay. Step 2, start with oxygen and do the same thing. So grams of oxygen, moles of oxygen, moles of the product, and you could go ahead and take that to grams of the product if you wanted. Okay. And then at this step, you're going to pick the smaller. Pick the smaller number. Okay. So that's what we did in the previous one. We went all the way from grams to grams, grams to grams, then we picked the smaller number. What this graphic from your textbook is showing us is if you wanted to save yourself a calculation, if you wanted to save yourself a step, you really could compare right here at moles. So you could go grams to moles to moles, grams to moles to moles, and pick the smaller number here. And then you'd only have to do 1 mole to gram conversion at the end. So if that just blew your mind, blew the top off your mind, ignore it, don't do it. Do it the other way that we talked about. But if this makes sense to you and it saves you a calculation, then you can do that as well. Okay. And then here's the slide that walks you through that process. So grams to moles, moles to moles, grams to moles, moles to moles, and then they did that last conversion. So the answer to this problem, whether you did it this way or the other way, the answer to this problem should be 70.5 grams of magnesium oxide. That's the most that you can make. This is a skill that you need to practice. Of course, your textbook, your homework's going to have some great resources. You can also Google limiting reagent problems, and you can get more worksheets with the answer key than you have time to do. So there's lots and lots of opportunities to practice out there. You just got to go find those opportunities and practice them. Hope you guys found this helpful.